What if you could literally design the perfect soil? I mean, what if you could take a piece of barren, dry land and just transform it into a farm that actually thrives? It sounds like something straight out of science fiction, right? Well, it turns out scientists are dusting off an ancient technology and giving it a massive 21st century upgrade to do just that. And this is the fascinating story of biochar.
So here's what we're going to get into. We're going to explore the incredible promise of biochar. We'll get a ringside seat for a scientific bake-off to find the absolute best recipe, and then we'll see how researchers tackled a huge roadblock with a really clever biological fix.
Okay, so let's start with the big picture problem. One of the toughest challenges we're facing is sustainable agriculture. And this is especially true in arid, dry lands where the soil is, well, it's just not great. It's often sandy and it just can't hold on to water or nutrients. This is the problem we're trying to solve here.
And the big idea? It's something called biochar. Now, this is not some brand new invention. No way. Its roots actually go back centuries to the legendary Terra Preta, the black earth of the Amazon, where ancient civilizations figured out that enriching their soil with charcoal made it unbelievably fertile. So what we're doing now is basically reverse engineering that idea, taking organic waste and cooking it without oxygen to create this incredible soil booster.
So why is everyone so excited about this stuff? Well, biochar is a true multitasker. It acts like a sponge, helping that sandy soil hold on to every last drop of water. Its structure is full of tiny little pores, making it the perfect home for beneficial microbes and helping it hang on to nutrients. And this is the really mind-blowing part. It locks carbon away in the soil for hundreds, maybe even thousands of years. It's literally pulling carbon dioxide right out of the atmosphere.
But here's where our story gets a little more complicated. At first, the hope was, maybe you can just throw any old charcoal into the soil and get these amazing results. But as researchers dove in, they figured out pretty quickly it's not nearly that simple.
And that brings up a really important question. If you're going to go through all the trouble of making biochar, how do you make sure you're actually making the right kind? Because it turns out using the wrong kind of biochar can actually do more harm than good.
The best way to think about it is like you're baking a cake. Your final cake depends entirely on two things, right? Your ingredients, what scientists call the feedstock, and your oven temperature, which for biochar is the pyrolysis temperature. If you change either one of those, you get a completely different result. So finding that perfect recipe, well, that's everything.
And that brings us to a 2022 study that was basically a scientific bake-off. Researchers set up a competition testing 3 totally different feedstocks, all of them common waste products, to see which one could make the best biochar for these tough, arid soils.
First up, we have composted sewage sludge. Now, this is an organic waste that cities all over the world producing huge, huge amounts. If we could find a good use for it, that would be a massive win for sustainability.
And the result here was a real good news, bad news situation. The good news? This biochar was absolutely packed with minerals. Awesome. The bad news? It also had heavy metals like lead and arsenic, and you definitely do not want to be adding those to your farmland. So despite the potential, sludge compost was out. First one down.
Okay, on to contestant number 2, mesquite. If you live in certain parts of the world, you know this plant. It's an invasive species that causes massive ecological problems. So the idea of turning this environmental menace into something beneficial, that sounded brilliant.
And on paper, the mesquite biochar looked like a total rock star. It had a massive surface area, perfect for holding water, and it was almost pure carbon. But then they put it in soil, and it did something nobody saw coming. It basically acted like an antibiotic, killing off the helpful microbes in the soil. So, another surprising failure.
All right, that left just one final contestant: date palm leaves. In places like the Middle East and North Africa, these are an incredibly common agricultural waste product. A lot of the time, they're just piled up and burned, which, creates a lot of air pollution.
And yep, this was the one. When they cooked the date palm leaves at that sweet spot, 600 degrees Celsius, everything clicked into place. The biochar had a great surface area for holding on to nutrients, and, this is the crucial part, it didn't hurt the soil's microbial life. We had a winner. But just when the scientists thought they had cracked the code, they hit another huge wall. There was a hidden flaw in their winning recipe, a problem that threatened to derail the whole project. So the winning biochar, it had a pH of 10.1. Now, just to put that in perspective for you, neutral is a 7.
So this stuff wasn't just a little alkaline, it was highly alkaline. We're talking almost like a weak drain cleaner.
And this is a total deal breaker. Why? Well, because the very soils they were trying to help are already alkaline. So if you add something that's even more alkaline, you just make the problem worse. It locks up essential nutrients and basically starves the plants. Their perfect solution was completely wrong for the environment it was meant to fix.
So what do? Scrap everything and start over? Nope. The researchers came up with a much smarter solution, which they detailed in a 2024 follow-up study. Instead of changing the recipe, they decided to treat the final product, and they used biology to pull it off.
The process they came up with is it's pure genius. Here's how it works. First, they add simple elemental sulfur to the biochar. Then, they mix in some compost, which is full of these amazing little microbes called sulfur-oxidizing bacteria. Those microbes get to work basically eating the sulfur, and as they do, they release sulfuric acid as a waste product. And that acid, it perfectly neutralizes the biochar's high pH. How cool is that?
And the result? I mean, look at this. It was absolutely stunning. This chart says it all. The treatment was a massive success, dropping that pH from a hostile 10.1 all the way down to a beautiful, plant-friendly, near-neutral 7.2. They had fixed the flaw. They had their perfect biochar.
So after this whole scientific journey, the bake-off, the surprise failure, the brilliant fix, what's the big takeaway? It's that we've really moved past a simple, one-size-fits-all way of thinking about soil.
It really boils down to this, a point the researchers themselves made. The future isn't just about using biochar, it's about creating customized biochar. It's about designing a very specific recipe to solve a very specific problem in a very specific place.
And that leaves us with a really fascinating final question to chew on. We design our computers, our cars, our buildings. What if the next great frontier in engineering isn't concrete and silicon, but soil itself? Could carefully designing the very ground beneath our feet be the real key to feeding our future? It's a pretty powerful idea to think about.